Here's an explanation of some of the ideas from section 7.5, the applications we talked about in class. So I want to start first with proportions. And what I wanted to say is when you're doing proportions, when you've got ratios of comparing two things and they're proportional ratios, there are usually two ways to represent the proportion. The one they have in the book is if you have A over B is compared to C over D. As fractions, if those are equal, you can rearrange those fractions to get a second relation, which is what I think of as the ratio of the numerators, A over C, if you can see that up at the top, is equal to the ratio of the denominators, B over D, up at the top. So you get two distinct pairs of fractions that are equal, and so you can use either of those. If one of them makes a nicer fraction, a reducible ratio that you can play with, sometimes that makes the mathematics easier. Let me give you an example. Or let me show you how it works first. So A over B equals C over D. If we use the ideas we used in the last class, where we clear the denominators by multiplying by the least common denominator, we multiply in this case by BD on both sides, the orange. And in that case, the B and the B cancel and we get AD, and the D and the D cancel on that side and we get equals BC. So essentially what happens is you're cross multiplying, right? The B multiply over there, the D multiply up there. And when you cross multiply across an equal sign, you get an equation, a relation without divisor, without fractions, AD equals BC. If you then take that and divide both sides by some common thing, let's say it's DC in this case, then I can reduce that because the D's cancel and I get A over C. And in this case, the C's cancel and I get B over D. So I have another proportional relationship, A over C equals B over D. And I can use either one of those fractions. So in these examples, we're going to have three of those variables. We have to solve for the fourth one. So pick whichever one makes that relationship easier to simplify and solve. Here's an example that we talked about in class. So pediatricians prescribe 5 milliliters for every 25 pounds of a child's weight. And the question is, how much should they prescribe to Amelia, who weighs 60 pounds? So proportionally, how many milliliters of medicine should she get? And I want to think about that in two ways. One is I can compare the small on the left, so the small amount on the left with the large amount on the right. And the ratio is going to be milliliters over pounds in both cases. So I get 5 milliliters over 25 pounds for the small situation, and that should equal X milliliters over 60 pounds in the big situation. So I get 5 over 25 equals X over 60. Alternatively, if I want to look at it with the milliliter ratio equals the pounds ratio, I get either I could do the small milliliters over the big milliliters, or I can flip it upside down. In this case, I'm going to use the big over the small. So the big milliliters over the small milliliters equals the big pounds over the small pounds. And so I get this relationship. X milliliters, which is the dosage for Amelia, over the 5 milliliters small dosage, should be Amelia's weight over the small weight. So X over 5 equals 60 over 25. I can get either of those two relationships, these two sets of fractions, and whichever one's easiest to solve, that's great. As we talked about in class, sometimes there's an intuitive way to solve that. And if you notice, like in this example, the 5 milliliters over 25 pounds, that means the pounds is 5 times your milliliters. So as soon as you know your milliliters is 1/5 of your pound, then you can sometimes mentally do the calculations and figure out what's 1/5 of 60, that's 12. Or you can do a simple calculation on your calculator if it doesn't quite work out, something you can do in your head. In any case, we can solve these and get 12 milliliters. How do you solve these algebraically in case the numbers don't work out so nice? Well, what you can do is take those same ratios that we had before, either doing the small equals the big, the ratio in the small side equals the ratio in the big side, or the ratio of the milliliters equals the ratio of the pounds, whichever way works to work it out. And you multiply by the least common denominator to clear denominators, which often is essentially cross-multiplying in some of these simpler cases. So in this example on the left, look at the two denominators, they're 25 and 60. We could factor out a 5 and make it simpler, but we could just multiply both sides by 60 times 25. And in this case, the 25s cancel, and we get 5 times 60. On the right-hand side, the 60s cancel, and we get 25 times x. Solve for x, and beautifully, we get 12 milliliters, the same as before. If you do it with the version on the right, you might see that the common denominator with 5 and 25, the common denominator is 25. So just multiply by 25 on both sides, like I did there. And the 25s cancel, the 25 and 5 leaves you with 5x equals 60, which through times the charm, it also equals 12 milliliters.